Any questions on nails? Hair. A hair follicle is an extension of the epidermis into the dermis. It's a tube that the hair is growing inside of. At the deep end is a hair papilla. Much like the dermal papilla, it has a capillary network in it to provide nutrients for the growing hair. The hair itself, what you see on the outside is the shaft. What's inside is the root. I didn't put it on the slide. At the base of the root, this was in the lab book, is the hair bulb. The part that's thicker, and that's where the growth is occurring. Attached to a hair follicle is an erector pili muscle. This is smooth muscle. It's involuntary. When it contracts, it makes your hair stand up. That's how you get goosebumps. M for muscle. So rect means straight. I'm not sure why it's spelled A-R instead of erect, like erecting a building, but there you go. Pill means hair. So, generally, the purpose would be to try to, the hair would trap air next to your skin and keep you warmer. Most of us don't have thick enough hair for that to work. It works on other mammals that still have fur. It also can make them look bigger. Anybody, when their cat puffs up, that's erector pili muscles. Questions on hair structure? Sebaceous glands produce your skin oils. They're found everywhere except your palms and soles. So those are areas you don't want to be as slippery. Most of them are going to secrete onto a hair follicle. So they'd be attached at the side, kind of like this, and have some little ducts in them. Around the mouth and genitals, there are sebaceous glands that secrete directly onto the skin, areas that don't have hair. There's still fine hair on your face where most of the sebaceous glands come out. The secretion is called sebum. Its purpose is to keep your skin and hair soft and to provide another layer of waterproofing than keratin alone would provide. Too much sebum can cause acne by clogging the pores of the sweat glands, and then bacteria can start growing in there. And you make more sebum based on your individual variations and hormones, which is why so many of us got lots of zits as teenagers. It has nothing to do with eating pizza or chocolate like your mom might have told you, unless you got the pizza oils on your face and then it added to the sebum. Questions on sebaceous glands? And also remember, these were the example of holocrine secretion, where the whole cell falls apart. So your sebum is all the little cell parts in addition to the oil. Sweat glands are long coiled tubes. This shows two different varieties. They both have this long tube and then it's coiled up at the deep end. some of them secrete into pores directly on the skin surface. There are other types that secrete onto hair follicles. Those are found in specific areas. The types of sweat glands are merocrine, apocrine, and specialized. The merocrine are the ones here that secrete directly onto the skin. Apocrine go onto the hair follicles. Specialized are only in certain locations, and their secretions aren't even really sweat anymore. The merocrine sweat glands are your major ones. They're found all over the body, but they're particularly abundant on the forehead, the neck, and the back, also on the palms. They produce mostly water with some salt and wastes in it, and its function is to reduce body temperature. Those wastes are why we could count integumentary as one of the systems that excretes. Although it doesn't specifically try to get rid of the wastes, you won't like sweat extra to get rid of them. The salt is the reason if you've been sweating a lot and only drinking water, then you're not going to do all that well. You need to replace the salt as well, and that's the purpose of sports drinks, is to replace those electrolytes. Any questions on merocrine sweat glands? The apocrine sweat glands, I've seen some textbooks that say they do use apocrine secretion, and some say they don't. So I'm probably not going to be particular on that one. There is more in the sweat than in merocrine sweat, including some protein and lipids. Those are nutrients for the bacteria on the skin. And when the bacteria eat those nutrients, that's where you get that stale, sweaty smell. Apocrine sweat glands don't become active until puberty, which is why kids, no matter how dirty they get, never have that particular smell. The apocrine sweat glands are the ones that secrete onto hair follicles, and they're found in the axilla and the groin, and sometimes around the nipples. And while they can help reduce your body temperature, they're more active with strong emotion like fear, pain, and arousal. Questions on apocrine sweat glands? Specialized sweat glands include ceruminous glands that produce your earwax and mammary glands that make milk. And that's the most complex secretion we have because it needs to provide all of someone's nutrients for one. Any further questions on accessory structures? Okay. All right. Our last section is on skin functions. Big ones are protection and preventing water loss, that it does just by being there. But then there are some more active functions to it. Our skin regulates our body temperature because it's the part of us that can lose heat to our surroundings or pick it up if our surroundings are warmer. Our sense of touch is provided by nerve receptors in our skin, and skin synthesizes some chemicals such as vitamin D. And that's the only one we're going to worry about, just to know that as a function. The body temperature we're going to take a closer look at. Preventing water loss, that's through keratin and sebum. We looked at body temperature in chapter 1 as an example of homeostasis. The receptors are called thermoreceptors. The control center is the hypothalamus. And it's your body temperature being too high or too low that makes the difference. That makes the stimulus. The effectors to change your body temperature are the merocrine sweat glands, blood vessels in the dermis, and skeletal muscles. So 2 of the 3 are in the skin. So if you're too cold, we inhibit the sweat glands because we don't want to lose heat when we're trying to retain it. That's the one that can get kind of tricky if you're exercising in the cold. You're creating heat from the exercise and you might start to sweat even though it's cold around you. Blood vessels in the dermis will constrict. What that does is there's less blood going to your skin. More of the blood stays in the deeper tissues where it won't lose the heat. So the purpose of these skin reactions is to retain the heat you have. Now if that doesn't do enough, if you actually need to add some heat, that's when you'll start shivering, which is muscles contracting. If you're too hot, then we'll stimulate the sweat glands, and the blood vessels in the dermis will dilate. That sends more blood to the surface where the heat can be released, and that's why you look red when you're hot. So, if you've got your slides, we can fill this out as a chart with both homeostatic loops on it. The blue is for we're too cold, so stimulus, too cold, receptors, thermoreceptors, control center, hypothalamus, which is actually highlighted on this little brain picture. So those two will be the same in both directions. Our effectors, sweat glands and dermal blood vessels, will apply in both directions. Here, the vessels dilate and the sweat glands don't secrete. If you're too hot, or I just said that all backwards. If you're too hot, the vessels dilate and the sweat glands secrete. If you're too cold, the vessels constrict, get smaller, and the sweat glands don't secrete. And then they put this one separately because you do this first, and if that doesn't warm you up enough, then we send messages to the muscles to tell us to shiver. Questions on body temperature? A couple of other little bits going along here, sorry. It wasn't the last section. Healing wounds. This often involves inflammation. This is a normal response to injury. You're probably all familiar with the symptoms, heat, redness, and swelling. Why those occur is there's more blood flow to the area. So the blood flow makes it red and warm, and there's also more fluid coming out of the vessels, and that's what makes it swell. That's useful because it can bring more oxygen and nutrients for healing and white blood cells to fight any infection. And they also clean up damaged cells. There's two main varieties of cuts based on how deep they go. A shallow cut, which damages only the epidermis. An example of this is when you get a paper cut and it hurts but it doesn't bleed. That damaged only the epidermis. There are pain receptors in it. So all you have to do to heal that is the basal cells start dividing more rapidly to make new cells to fill in the gap. A deeper cut that gets into the dermis and breaks blood vessels is going to go through 3 stages of healing. The blood fills the opening and clots. That's your first stage. Then epidermis can grow pretty quickly. The cells are going to divide and grow around the clot. And then the fibroblasts in the dermis work to rebuild it. That pushes the epidermis back up. At the same time, some white blood cells are shrinking the clot. And so the clot will get thinner, the epidermis will move up as we build more fibers in the dermis. So here's an illustration. We've got loose blood that's clotting. White blood cells are already on their way. Here, The clot is finished, the epidermis is grown down along the edges. We've already got some white blood cells in there, shrinking the clot. And we've got some fibroblasts working on the dermis. Here, the epidermis has gotten thicker, but it's pushed up. The clot is thinner. We've got more fibers going. And then here's where you've just got a little residual bit of a scab left. The epidermis may have been made a little extra thick at that time, but that'll thin out to its normal size over time. Now you can end up with a scar if there's a lot of damage and you get extra collagen built that's showing through the epidermis. Questions on wound healing? Burns, we used to call them first, second, and third degree based on how deep it is. And those match up with these numbers. We're going more towards something descriptive. A superficial partial thickness affects only the epidermis. So your skin will be red for a while, but gradually those cells that were damaged get